Welcome back to Building on the Rocks. This is episode 4, Computational Design, where nature meets code. PR specialist Mike Newby is joined by Professor Pankaja Bagul to explore how computational design and digital tools are reshaping the future of construction.
Pankaja, welcome to Building on the Rocks.
Thank you. I'm looking forward to the talk.
So am I, because today we're talking about computational design, and I know that that is your speciality as not only an academic, but also as a consultant in the industry. So we're going to start our conversation with a quote from a master, Lewis Sullivan. He said, "Form follows function." And thinking about that quote, do you think that needs to change in the digital age?
I wouldn't say it needs to change. It remains form, always follows function. But it may change because people are using more different materials which have got different potentials, performances. So form can change as per the availability of the material or the use of the material. So as per the performance of the building, maybe the form may change and still function very good.
Okay, crazy hypothetical question for you. If you could program any building to do one thing automatically, what would it be?
Just I know the answer to that. I would want the light and ventilation to be automatically adjusted as per the changing climate outside throughout the year. And now it's possible because of all the tools.
I love that. That sounds like a dream. No more arguments over the thermostat.
Sure.
Thinking of the kind of digital and parametric tools of architecture today, what do you think is the most transformative aspect of that technology?
The most transformative aspect is the versatility in design that it offers. You can cater to a number of requirements of the client and produce a number of options. And every change earlier used to take a lot of time. So architects generally had 2 or 3 options, and then the client would to make a change. It was just difficult to incorporate. But now, because it is a process-driven method, a parametric design is a process-driven method. All are relational models that we make. And if we make one change at one place, it automatically gets reflected everywhere. So the change in the design, the variations in design, till the end is possible. And it's a very efficient way of designing now. So I think that is one change I appreciate a lot.
Yeah, that sounds very efficient. It's like that old expression, back to the drawing board. You can throw that out the window now. So I've heard, often I think of architects, because I'm just this kind of guy. I think of architects as sculptors in steel and glass. Do you think they're becoming poets as well, poets of code?
Yes, you could say that, because writing poetry and writing a good code is skillful in itself. So I think there are engineers who write a wonderful code, and writing a prompt or writing a good algorithm is a skill set that architects need to have now. So when you set out a problem or you set out the brief for the client, that is writing poetry, I would say. So if you write out an algorithm which is going to be translated into design, that is the thing. That is what is going to make a good designer now.
And the critical thing is it's still creative, is it not?
It is, yes.
So can you give us an example of a project that was only possible because of the advances of computational design?
The project that comes to my mind is the Al-Baha Towers, where a dynamic facade was created for bringing in the change in the climatic conditions inside. So the dynamic facade responded to the climate outside and brought in the comfort levels and adjusted the comfort level inside within the building. So that was like controlling the sunlight and the heat gain within on the facade, and there was a corresponding change inside the building.
So that's in Abu Dhabi, isn't it? So the problem that's solving is quite a serious one because of the environment.
Yes, it is. That was a great problem earlier because we had fixed They have the sun shading devices, and as you know, everyone is on mechanical ventilation, air conditioners. So it is automatically responding. So there is a lot of energy saving, I would say.
And saving on human effort and
Yes.
time. Yeah. How are digital tools enhancing off-site and modular construction?
Modular construction, I think digital tools are offering various ways in which they can be assembled. So because you can write a program or a code, how they can be assembled, and then in which pattern, and the robotic construction will allow you to pick and place it in any place you want. So you can have a number of variations for the same for the same size of panels, and that is the one thing that is the innovation that's happening. So earlier we had all panels in one line or something, but now you can change the geometry, you can change the variables, and then find out what looks best and what are the better options available.
That's interesting. It sounds like computational design is driving some changes in efficiency and also
Yes.
aesthetics.
Yes, aesthetics, yes.
Can you think of any standout examples?
I would say aesthetics, curvilinearity is one that people are exploring. People are going back to organic design, like designing in nature. And there is one, Jean Noel has designed one Louvre museum, and that has got a sun shading roof, which turns automatically to let the light in. So that is one advanced kind of a design, I would say. So it brings in the filtering light.
So I'd imagine in this new digital world, material performance is more in focus. Do you expect things like stone wool to pick up in terms of how widely it's used as a result?
Yes, obviously, because of its properties. It's got the duality of it can have steel as its cover, or you can have, it has got, maybe you can have the surface in a different material and stone wool inside. So it's mainly used for insulation, and its fire resisting properties are a lot. So in terms of performance, it's a very high yielding kind of a material. So it's got a lot of potential, and people are going in for lighter buildings. So sound insulation is also one of the important properties which stone wool gives.
So that raises a question. We've talked about how computational design affects the efficiency of the construction phase, but the ongoing efficiency, can it make buildings more energy efficient? Can it make them safer? Can it make them just more livable?
Yes, like I said earlier, that it is possible and it's happening. And I believe that because of the building information modeling, which is happening parallel to the design. So as you design, you are giving in inputs for the materials, the material choices you're going to have, and you're checking for all the inputs. So if you're looking for safety, if you're looking for the audits that you need to do for the green building, all are happening parallelly as you are designing. So it's like a process, an integrated process. And this is the most exciting part, and I'm sure all will be taken care of.
Well, you've converted me. You've completely convinced me. So let me put a statement to you and just see if you agree with me. Computation equals less waste, more flexibility.
I agree with you. Yes, it is surely, because everything is finalized on the board.
So with tools that make you more efficient, sometimes there's a risk that they can make you cut corners. And I know people are feeling trepidation about AI for that reason. As code takes center stage with design, what are your hopes and what are your warnings?
Yes, that's very true. In a positive sense, it's great. However, people will tend to, I'm concerned is that people will forget that it is a tool and they might over-rely on it. And that would create a lot of problems, because as a designer, you are catering to the needs of the client, of the human being, and the performance of the building, or creating environments for people to be comfortable in, and it should function as it has been. However, using AI and coding, people may just build structures that may not be that comfortable, or they may alienate human beings from the design itself. So as long as it's going to be used as a tool, And I would say, as a partner in design, it would be very good.
And I suppose design is a joyful and creative experience, and
Yes.
we want to make the job easier, but we don't want to remove that.
Yes, we don't want to do it. So creativity is the one thing that is driving everything.
One question that people might have is, can code-driven buildings be human, and how?
Sure, because it is upon the architect who is designing, and most designers are now taking decisions. As we discussed, that sustainability is one thing that everyone is very conscious about. Building with nature, as I told you earlier, that nature is, everyone is taking inspiration from nature, and nature is human, it caters to the human needs, and the scale is also human. So the scale is the most important thing, where people feel alienated, and the comfort level. So the performance of the building, if it is comfortable, then people feel at home. So these can be controlled by the computer and the information that we are giving in. So I think it is perfectly possible for us to have that aesthetics of the human scale, as well as the performance and the comfort levels within the building.
Because ultimately it's driven by code, but there's an architect, a human architect, making
Yes,
decisions.
just making the decisions along with the client, I would say. Yes.
Pankaja, thank you so much. We're getting towards the end, so I've got a quick fire round of questions for you if you're ready.
Yes, I'm really excited to know what it would be.
Okay, here we go. Strap in. One tool you can't live without as a designer.
My digital notepad.
Good that it's digital. Your wildest prediction for digital construction in 10 years.
It would be seamless construction from the computer to the site.
Okay, so what's the best use of stone wool in a computational project?
I would say it would be for fire resistance and insulation.
Thank you so much. Now, going back to that quote at the beginning from Lewis Sullivan, form follows function. After our conversation, do you think maybe we need to update that?
Yes, I think I would do it now. Form follows innovation would be the update.
That's very nice. Thanks, Pankaja.
Thank you so much. Yeah, it was fun being here.
You've been listening to Building on the Rocks, brought to you by ROCKWOOL Core Solutions. Don't forget to follow us for more conversations on where design and innovation meet.